Inert electrodes, I wanted to mention this. The electrode at the cathode can be switched out for something inert. I think I very briefly mentioned this on Thursday. So this electrode here at the cathode, we could switch this out for an inert electrode. For example, maybe it was gold depositing on here, right? Well, gold would be an expensive thing to make an electrode out of, right? So there, maybe you would want to make the electrode out of something inert. What's something inert? Platinum, right? Which is probably more expensive than gold, right? But graphite, also an inert electrode. And then what will happen is, say I made this electrode out of graphite, we would just plate solid copper on the surface of the graphite. Now, it would make it maybe harder to recycle, okay? But you can replace the electrode. Now, you cannot replace the electrode at the anode. The anode electrode actually dissolves, right? That's what's releasing the electrons, okay? So just a quick thing there about inert electrodes, no big deal. Cell line notation, I want to mention this quickly. In cell, so here's a zinc copper battery. This is a fast way, it's called cell line notation. This is a fast way to draw a battery without drawing it, okay? What we have here is a single line represents a phase change. So here would be like my zinc electrode at the anode dissolving into zinc plus 2. And then again, here's a phase change. Here would be my copper ions at the cathode depositing a solid copper on the electrode. A double line represents the salt bridge. So this is just a really easy way of kind of representing a battery without drawing the whole thing. So like here's your one beaker, here's your other beaker. This is an electrode, that's an electrode. It's like a fast shorthand way of representing a galvanic cell. I would like you to try and predict. You do not need to draw the battery. Okay. I just want you to try to use that standard reduction potential table to predict the voltage for each of these batteries. Okay. So take a second. That bottom one is kind of pretty crazy. Okay. But we'll go over that here in a second. All right, folks, let's do this thing. So let's do this top one. We are looking for nickel plus 2 electrons goes to nickel, and I see it right here. That's always nice. Negative 0.23 volts on that one. Negative 0.23 volts on the nickel. And now we're looking for the reverse manganese here. So we're looking for manganese plus 2. Oh, yeah. Manganese goes to manganese plus 2 electrons. That becomes a positive 1.18 volts. So that becomes a positive 1.18 volts. And we're going to add that up. And we get a positive 0.95 volts for that top battery. That would have a voltage of positive 0.95. The bottom one, here we go. That aluminum one should be pretty easy to find. It is being reduced, so that's good. That one will be as is. And we found it right here. That is a negative 1.66 volts. Negative 1.66 volts. And now we got our work cut out for us. We got to find this crazy guy, and it's going to be reversed. It's going to be like nitrate plus 4H plus some number of electrons, blah, blah, blah. Let's take a look for it. So we're going to look for nitrate. Nitrate plus 4H plus goes to NO and 2H2O. There it is. That one got, this one is an oxidation, right? Okay, so we have to flip it. This one is negative 0.96 now. So that's a negative 0.96. We add it up, we're going to get a pretty negative voltage here. So negative 1.66 minus 0.96 or plus a negative. This is a negative 2.62 volts. So this is really important. What does it mean if you get a negative voltage? If you get a negative voltage, here's what that means, folks. It actually means that the reaction or the galvanic cell is hooked up backwards. and you are going the wrong way. It's actually going to run this way. And if it goes this way, it would have a positive 2.62 volts. So we're going to talk about the relationship between voltage and spontaneity and equilibrium constant here in a moment. But if you end up with a negative overall voltage, it actually means that it's non-spontaneous in that direction and is spontaneous in the reverse direction with the opposite sign voltage. So in the reverse direction, it would be a positive 2.62 volts.